students, today we'll study motion. Okay, this motion that is very related to our daily life. Suppose you are going for morning walk, that means you are in motion. You are going to buy something in from the shop, you are in motion. You are going to school and you are coming back from school. So motion is related to our daily life and every point of our life. So here in this lecture, I will cover the concept of rest and the motion and different types of the motion. So you are in a rest condition when I can say this, or you are in a motion condition when I can say this, or different types of motion also we'll discuss here. That means suppose in a crowded place you can see that your car, if you are driving the car, your car will be in motion, but not in a regular distance or equal distance it will cover, right? Sometimes you have to slow down your car, sometimes you have to brake your car. So that means there are different types of the motion you can see in your daily life. And one type of motion that is very, very well known to you, that is your wristwatch. You can see tick tock sound from your wall watch. So this type of motion also will start. Okay. So from this picture, it is very clear that the tree very near to my house, that is stand still, it is in rest. The home, this is also in rest. The electric pole, this is also in rest. But the motion, I can see the birds are flying in the sky, the insects are flying around me. So here you are playing football. So these are the motion. And here you can see that the person, he is driving the bike and the other persons who are standing and just enjoying the race, this picture of those persons are blurred. So here this is in motion, right? Now, if you are saying that it is in the rest, it is in the motion, so the object is in the rest or motion, what do you mean by that? Here, if an object is not changing relatively to a given frame of reference, the object is said to be at rest or motionless or immobile, stationary. I am giving one example to describe this thing. Suppose you can see your ceiling fan is moving while you are stand still there. At that time, with respect to you, the ceiling fan is moving, right? That means what? You are the frame of reference. You are the frame of reference. Suppose you are sitting in a chair and in front of you, you have laptop. So you can see that your laptop is in rest. Also, you are in a rest condition. How? Because the laptop is the frame of reference. Whenever you are saying that you are in a rest condition, or your laptop is a frame of reference, or you are a frame of reference, right? Whenever you are a frame of reference and your laptop is not moving anywhere, at that time you are saying that yes, my laptop is in rest condition, right? So the rest condition that should be defined in terms of the frame of reference, and it sometimes we are calling motionless, immobile, stationary. You heard this time immobile things, your home. I cannot take my home to anywhere, right? So my house, that is immobile things or stationary things, right? One tree you have, so in front of your home, that is also stationary. That means that is rest, in rest condition. But in physics, the motion, that is the change in position of an object with respect to its surroundings. That means what? I am playing, or I am in a motion, I am playing the football, I am in a motion, or you are in a motion. Whenever you are playing the football, you are in a motion with respect to what? With respect to the field that is not moving, right? With respect to your poles, electric poles, you are in motion, right? That means the motion, that is the change in position. So if you are here now and you are playing the football. After that, you just throw the football, then you can see that you just ran away from this initial position. So here you can see that now this is the new position. So there is a change in position. That means here you were and now you are 5 meter distance from the previous position. So this is the change in position and in a given interval of time. In a given interval of time. In a given interval of time. So that means suppose for this 5 minute or 5 minute you are taking, for this you are taking 5 minutes. Okay. So that means what? I am in this position after certain time, I am at this position and which is 5 meter away from the initial position. So there is a change in position with respect to its surroundings in a given interval of time. That is the motion. Okay. Now the frame of reference which I have told you, whenever you are describing the rest or motion, always it is a relative parameter. Okay, and it is relative parameter because the frame of reference or with respect to which point you are considering you are in motion, that is called the frame of reference, right? The tree is in rest. Why you are saying this? Because with respect to your house, it is not moving. That's why your tree, the tree in front of your house, that is in rest condition. Now, here in this picture, you can see that two person, they are sitting in front of this window. At one side, this lady is here, and other side, this lady is here. Okay, suppose this is A and this is B. That means if A, this person is saying the B person, then she can see what? She is in rest and she is just searching her mobile, and B person with respect to her, if she can see the person A, at that time she also can see that she is in rest condition. But see the outside of this window, what you have, one platform and another railway track. So with respect to railway track or platform, the train is moving. So whenever you are saying that, with respect to point A, suppose this is myself. Okay. So with respect to point A or with respect to this person, I am in rest, but with respect to railway track, I am not in rest. I am in motion. With respect to railway track, I am in motion. Right? And first case, your frame of reference is what? The person A. Second case, your frame of reference is what? The railway track, right? So if frame of reference is different, at that time you can see that the same person, B person, she may be in rest, may be in motion. So the frame of reference is very, very important. Frame of reference is very, very important. Okay, so that means one person can be in rest, can be in motion, but it depends on the frame of reference. So here, everyone in this world, all of us that we are sitting anywhere, we are thinking that we are in rest condition. But you know that this is our lovely earth and it is revolving around the sun always, right? And this question is very valid question. Did you know that everything in the universe is always moving? Do you know that? Here, just we want to explain this. This is the axis of the earth. And you know that the earth is moving along this axis. The earth is moving along this axis, rotating, right? And there, the earth is also, it has also another movement that is around the sun, around the sun. So there are two movements present in the earth. First is the rotation and second is the revolution, right? So if I am sitting here, that means I am also moving with respect to this axis. Yes or no? Yes. If I consider that this is the sun, that is the frame of reference, if I am on the surface of the earth, I am also revolving, right? I am also moving around the sun. So how I can tell one thing, if I am sitting in the earth surface, at that time I am in a rest. I am not in a rest condition. But if my friend, he is also standing in this surface, that means surface of the earth, with respect to him I can say that yes, I am in rest. But with respect to the axis of the earth or with respect to sun, I cannot say that I am in rest, right? That means I am in rest if the frame of reference is the one friend who is sitting on the surface of the earth. But if any person who is in the moon, he or she is just seeing this view, at that time he or she will tell that no, you are not in a rest condition, you are in a motion condition, right? So Mr. Question Uncle, very sweet uncle, he has some questions. Define rest and motion. So rest and motion, obviously the frame of reference is very important. So we have to describe it in terms of frame of reference. Frame of reference. Without this point, you cannot define rest or motion, right? Another question he has, that is, the can a body be in a state of rest and also in motion at the same time? Obviously, just now I have described. In a train, with the example of the train passenger, co-passenger. With respect to co-passenger, you are in a rest condition. With respect to railway track, you are in a motion condition. With respect to sun, if you are sitting anywhere, you are in a motion condition. With respect to your friend, you are in a sitting condition. He is also in sitting condition. So, with respect to your friend, you are in a rest condition. So, yes, any object, anybody can be in a state of rest as well as in a motion at the same time. At the same time. Okay. Bye bye, Mr. Uncle Question. Now, this is the types of motion. Okay. So, the main types are uniform and non-uniform motion. So, uniform motion, the name also signifies something, uniform motion. Uniformly you do one thing or non-uniformly you do one thing. So, here you can see that if I can see these letters, there is some uniform space in between these two letters. This is uniformity. But here you can see that the gap is more. That is non-uniform, right? So here, in this way, we can also explain the motion. Suppose the car is moving in a highway. Suppose the car is moving in a highway. At that time, you can see that, yes, this car in a uniform motion. But whenever this car in a crowded area, this car is moving through a crowded area, at that time, sometimes it may be to avoid the collision with other car, sometimes it has to be take the action. What is the action? Sometimes it may be, it should slow down or sometimes it may take the brake. Okay. Similarly, the train also, you can see if it will move in a straight line, then it will take the 120 kilometer, it may cover this distance per hour. But whenever there is some junction and it has to move, follow this junction, this path, then again it has to change its the total distance covered per hour, right? Per unit time. Okay. So that means that is the non-uniform motion. Here the definition of the uniform motion. So this type of the motion is defined as the motion of an object in which the object travels in a straight line. Object travels in a straight line and its velocity remains constant along that line as it covers equal distance in equal intervals. Equal distance in equal intervals of time. That means what? I am moving 5-meter distance for 1 minute. Or I am moving 50 kilometers per hour. It may be through my car or anything else, but this is that means for first hour I am moving 50 kilometers, for second hour also I am moving 50 kilometers. I am covering the distance 50 kilometers. So that means equal distance in equal intervals of time. So here this graph also explains a lot of things. Here you can see that for the first minute, the distance covered, that is the 10 meter, and for the second minute the distance covered 20 meter. So what is the difference between these two? That is 10 meter. That means for every second it will cover 10 meter. For every second it will cover 10 meter. It may be the 5th to 6th second, it may be for 4th to 5th second, or it may be for 3rd to 4th second. So whatever, but equal interval of time, for this equal interval of time, I am covering 10 meter distance. The same distance I am covering, right? That means what? The equal distance I am covering for equal time interval. So if a body is involved in rectilinear motion, the motion is consistent. That means there is a consistency for the distance coverage, right? And the acceleration of the body must be 0. That means what? That means if I am covering 10 meter for this span of time, I have to cover same distance for this span of time. I should not cover 20 meter for this span, right? So if I will cover 20 meter, then it will be, yes, I have speeded up. So that should not be here. Now these are the examples of the uniform motion. As I have told you, if the speed of your car is 10 meter per second, so 10 meters in 1 second it should cover for whole the journey. That is, at that time we can say that yes, your car in uniform motion. And movement of the blades of ceiling fan. Suppose you have one ceiling fan and this is regulator. We are controlling the speed of the ceiling fan, and here you have suppose 4. That means whenever you are keeping this point at 4, that the blades will move in a particular speed, right? These are the examples of the uniform motion. The aeroplane, whenever it will be at a very high height, at that time it will be in a steady speed. A car, whenever it is moving through the highway, at that time it will maintain the same distance for same interval of time. A ship also, it will maintain the same distance. A train also, whenever it will go moving through the straight tracks. Okay. Then this is the non-uniform motion. So uniform motion is clear. Now we are switching to non-uniform motion. Fine. So what is the definition? For non-uniform motion, it is defined as the motion of an object in which the object travels with varied speed, and it does not cover same distance in same equal time interval. Same distance in same equal time interval, irrespective of the time interval duration. So this I will explain with the help of this graph. Here you can see that if I consider 1, then this much distance has been covered. For second minute, this much distance has been covered. For third, this much distance you have covered. So is this difference is equal to this one? No. Right? Again you can see that for this point, the same distance you have not covered. This difference is not equal. That means what? The differences in the distance covered for per unit time, that means per unit minute, you can see that it is different. right? It is a big distance for this second to third minute. Within this third to fourth minute, you have crossed only a little distance. So sometimes you are slowing down, sometimes you are just moving fast. So this is the non-uniform motion. So if a body or object is involved in rectilinear motion, if the motion is not consistent, that means equal distance you are not moving for equal time span. So that is called the non-uniform motion. And here the acceleration will be non-zero. Sometimes I am slowing down, sometimes I am just moving fast. That means whatever the acceleration, it is not zero. Change of the distance with respect to span of time is not zero. So this is the example where I can explain very well. Here you can see that from 0 meter to 1 meter, I am moving within this 2 seconds. Fine. My car is moving 1 meter to 10 meter for the second 2 seconds. From 10 meter to 25 meter for the third time interval. So first time interval, how much distance I have covered? 1 meter. For the second time interval, how much time I have covered? 1 meter to 10 meter, right? I move, final position is the 10 meter, that means 9 meter I have covered. Then I am moving to 25 meter, right? Then I am moving to 25 meter. Okay, so 15 meter I have covered. So that means what? But time interval is fixed here, 2 seconds for every 2 seconds. The first span of time is 2 seconds, the second span of time is 2 seconds, third span of time is also 2 seconds. But the distance covered, that is not equal. That is not equal. So this is the non-uniform motion. The distance covered should be equal for uniform motion. For non-uniform motion, it is not equal. So the example may be of your car, maybe motion of the train. You can see that whenever platform is coming and the train, it has to stop there. At that time, it will slow down, then it will stop there. After that, again, it will just take that speed, again, it will move. Okay. So what it will do, the train or motion of the train, that is non-uniform motion. Okay, because it is not possible, no, for the whole journey of the train, it will move through a straight track. It is not possible. Some bending will be there, some platform will be there. For to stop at the platform, it has to slow down. Then again, whenever it will restart from the platform, then again it has to take some speed, or it has to move fast, right? So these are the examples of the non-uniform motion. Now another a lot of examples I am giving here: a horse running, a man running in the 100-meter race. This is very familiar with you, because in your competition you can see in your school. A bouncing ball, whenever you are just bouncing the ball, you can see that suppose from this height you are bouncing the ball. First time it will touch the ground, then again it will bounce back, it will be here, then again it will bounce here, again it will move here, right? After bouncing here, again it may be here. After finally it will be at the ground. So this is the bouncing ball. That means the same height, it is not moving. So it is non-uniform motion. A car colliding with another car. Thank God, it should not happen. So whenever a car colliding with another car, obviously it will slow down, because we have to avoid this condition. Plane moving through the clouds and then landing. At the time of landing, you can see that the aeroplane, it is taking very high speed whenever it will move through the runway. Dragging a box from a path. Whenever you are dragging some box, it is not always that you are taking same distance for same time span. A bus on its way through the market. Market means very crowded area. So the bus is moving with a continuous, consistently, it is not possible, because so many people are there, so many traffics are there, so it cannot be, right? A train coming to its terminating points or spot. It may be the platform. So at that time, I have told you it will slow down. Movement of an asteroid. So that is also the example of non-uniform motion. Now, this is the comparison of uniform and non-uniform motion. The average speed for uniform motion, the motion is similar to the actual speed of the object, where for non-uniform motion, the motion is different from the actual speed of the object. Rectilinear motion, it has zero acceleration, it has non-zero acceleration. Distance time graph shows straight line. As you have seen, this is straight line, but for this one, you have a very curved line, or it may be this type of distance time curve. And distance, it covers equal distance in equal time interval. That means what? For time, equal time span, it will cover equal distance. But here, what we have seen in the picture, for first 2 seconds, I have covered 1 meter. For second 2 seconds with my car, I have covered 10 meter. Then after 15 meter. So different distance I have covered for equal span of time. So that is the non-uniform motion. Okay. Thank you.